Welcome to Conservation Fridays, where nature meets neighbor. I'm Rachel France.
And I'm Jamie Lewis Hedges. Today, we're thankful to have Adeline, Addie, Dutton Meyers, Addie Meyers, a dedicated fisheries biologist serving as part of the Southern Lake Michigan Management Unit for Michigan Department of Natural Resources. Addie holds a Bachelor of Science in Fisheries and Wildlife Management from Lake Superior State University and a Master of Science in Fish and Wildlife Management from Montana State University. Addie has researched endangered Pallid Sturgeon in the upper Missouri and lower Yellowstone Rivers, where she worked on estimating population abundance, quantifying diet overlap, and building qualitative food webs to better understand species relationships and food limitations. With Michigan's DNR, Addie oversees fisheries management in both inland and Great Lakes waters across 24 counties in southwest Michigan. This includes managing fish populations, assessing aquatic connectivity, and addressing conservation concerns related to freshwater mussels and habitat preservation. She is responsible for reviewing permits that impact waterways within the public trust doctrine, ensuring that conservation efforts are upheld and future generations can enjoy Michigan's world-class fisheries. Addie also serves as the chairperson for the Coldwater Resources Steering Committee, a group tasked with providing input, advice, and recommendations to the DNR on Michigan's coldwater fisheries resources. Addie is deeply committed to engaging with youth and the public to foster an appreciation for nature and conservation. She organizes educational programs such as walleye pond events, where local elementary school students get hands-on experience with fish and aquatic life. Addie's passion for conservation and dedication to community engagement make her a valuable asset to the fisheries management efforts in Michigan. Outside of her professional responsibilities, she's a passionate hunter and avid angler. Addie, thanks a lot for joining us today on this podcast.
Thanks for having me.
I didn't know you were from Lake State. I went there for one semester.
I loved Lake State. It was awesome.
Yeah. My sister went there too. She actually is, she started the women's hockey league there.
Really?
Gosh, I don't know how long, 10 years ago now. Anyways, we're really excited to have you here and to discuss fisheries, fish biology, aquatic organism habitat, fisheries ecology, and fish conservation in Southwest Michigan. But before we dive in,
are you passionate about protecting the environment and making a positive impact in your community? Consider volunteering with your local conservation district. By joining forces with your local conservation professionals, you'll support efforts in natural resource management that safeguard our communities. Whether it's tree wrapping, habitat restoration, water quality monitoring, or educational outreach, there are countless ways to contribute to the preservation of our natural areas. Join our dedicated team of volunteers today and be part of the solution for a greener, healthier future. To volunteer with Berry Conservation District, sign up at berrycd.org/give. That's BARRYCD.org/GIVE. Rachel?
all right, Addie. So other than your work as a fish biologist, what do you like to do? What hobbies or interests do you enjoy when you're not out in the field or behind a computer, as many of us often are?
I think the obvious answer that isn't shocking is I really like to fish. I like to trout fish probably more than anything and really like to ice fish when we have safe ice. I like to hunt. I have a bird dog, a Brittany, so really into upland bird hunting, like to deer hunt, like to waterfowl hunt. The non-natural resources hobbies that I think are maybe slightly different than my colleagues is I like to garden, and I like to cook, and I really like small children. So I like to babysit and spend time with, family or other people's small kids.
Well, hey, I actually
Oh,
need a
sorry.
babysitter tonight.
Yeah. Babysitter. Oh my gosh. And good babysitters are very carefully kept to the parents that have them. They have a hard time sharing them. Sorry for running across you there, Rachel. I was going to jump in and ask because I'm curious. Do you remember your first deer?
Oh yeah. Yeah.
Can you tell us
I
about that?
I was a late bloomer on the deer hunting aspect of things. I was a full-fledged buck fever, more like brown deer fever child of hunting. So I didn't shoot my first deer until I was actually a sophomore at Lake State. Um, yeah, when I was there, my parents had a place on Sugar Island, and my dad came up and we did deer camp together, and it was really cool. So I was a lot older than most people who hunt a lot when they shot their first deer.
That's really awesome. So everything you learned about deer, or I should say most things you learned about deer hunting initially were from your dad?
Yeah, both of my mom and my dad both deer hunt. Pretty, I would say, not super serious, but growing up, we ate venison regularly, and so probably from the age of, I would say, 8 or 9, when either one of my parents would shoot a deer, we would bring quarters in on the kitchen table. And I can vividly remember, like, my job starting around that age was I would get a front leg that was destined to be burger and a like small children's paring knife that I wasn't going to chop my fingers with. And I just had to cut all of the meat off to go be processed to be ground. And so, yeah, deer hunting's been a huge part of my life since I've been little.
That's terrific. You're bringing back recollections I have of when I was first introduced to deer hunting, and we would hang it up in the garage. And as we were processing the deer, we had the barbecue pit started up, and as pieces would come off and go on that at the same time. It's really a good time. Thanks for sharing that. You probably don't remember your first fish that really hooked you.
No, my parents tell people stories of, so I grew up in Fife Lake, which is kind of near Traverse City. My parents would fish on Lake Michigan, like in Grand Traverse Bays. My parents tell people stories that they would take me in my little life jacket and I would maybe be interested for a couple hours. And I spent, 75% of the time sleeping on the bottom of the boat. And I think that's why still today I don't get sick on the boat, even no matter how rough it is. Like I could sleep on the bottom of the boat when other people would probably be throwing up. So
That's awesome. Um, so I guess that is a pretty good bridge. Is that maybe what kind of influenced you into fish biology and fisheries management, or was there a particular moment or experience that really kind of defined that choice of the direction that you wanted to go?
so originally I I didn't really know that you could be a fish biologist. I didn't know that was a career, but we had a local conservation officer in our county who was a female, and she was awesome and I really liked her, and she was the one who kind of told me like this is an option. And when I went to Lake State, I was dead fast set. I'm going to be a wildlife biologist because I want to handle like cool, cute, furry critters, which is, I think, how many people get into fish and wildlife. And people who know me, this next part of this is not going to surprise them. I went to Lake State and I had a bunch of dual enrolled credits from when I was in high school, and I had was a little bit of a geek and really liked math, and I had Calc 1, Calc 2, and half one semester of Calc 3. When I got to Lake State, I couldn't get into Algebra 2. Like they wanted me to take Algebra 2 even though I had all these calculus credits, and I needed that to get into a wildlife class, and I was frustrated because I'm like, I don't want to take this class. I have all this other calculus. And so I was like, you know what? Screw it. I'm not going to get into this wildlife class. I'm going to take the fisheries equivalent. And then I never looked back. Like that was like the turning point. After that, I took a bunch of wildlife classes, but I knew after that I only wanted to do fish.
That's awesome. And that's kind of when I went to Lake State, I tried to transfer my maths and didn't. I had to take, they had it was like algebra 1 through 3 in one class, and you were supposed to test out, and it didn't go well for me. I'm good at math, but not that good. So,
I had a similar, I'll let you get back to that, Rachel, but I
yeah.
had a similar experience in my master's work. I took the lame way out because there was a route we could go without having the second language mastery equivalent, and I just didn't want to deal with that, and so I went the interdisciplinary studies route, which I ended up being a big advocate for, and it was a good experience for me. But my initial reason was to skip out.
I think that happens to a lot of people in college. It's like my class isn't available, or I don't, for me, it was chemistry. What can I do to get out of chemistry? I can't. And I thought I did, but I did not. But anyway, so for our listeners who might not be familiar with fisheries science and really what it is that you do, can you tell us a little more about what it is, why it's important, especially here in Southwest Michigan?
Yeah. So I would say fisheries management is extremely broad. I often tell people that if I had to give someone an elevator speech about what I did, then we should be going up at least 20 floors to give somewhat of a clear picture of what's going on. So I like to think of my job often as the seasons go. So if you think about things that happen during the seasons, and that relates back a lot to how fisheries science works in my position. So in the winter months, I'm doing a lot of writing. So trying to analyze data that we've collected and understanding how that data specifically relates back to a fish population or aquatic ecosystem that data came from. From March through, maybe June, we're really working on collecting lake data. So understanding inland lakes specifically and how the fish communities are important in those lakes, and how potentially things like how much oxygen is present could affect the fish community. Then we switched to streams, and especially in Southwest Michigan, we're really interested in stream temperature because the temperature and the quality of how clean and cool the water is, and how much oxygen is present really depends on what kind of fish species might live there. So is it a trout stream, or is it going to be dominated maybe by like smallmouth bass? Then we swing into the fall, and then we're thinking about, okay, we've worked on lakes and streams. We don't have a lot of like levers that we can pull to help these systems, but the levers that we have, we need to really start putting those into place. And that might be like stocking walleye, for example. So we do that kind of stuff. And then it's like the cycle repeats itself. And intermingled in between all of that is reviewing tons of permits for development projects or other type of projects, talking to people. I spend probably 40% of my time talking to people in some kind of fashion. And then also intermingled between all of that is trying to find time to actually think about how the fish are the number one thing of my job.
Wow. You said a couple of things that I want to ask more questions about. When you talk about the data and going through that, I'm wondering if you can help us understand how much data do you have to work with, and how does that data get there?
Yeah, absolutely. So when you introduced me, you gave a pretty broad view of how large my area is. And so for lakes, we typically will survey a lake within my coverage area once every 30 to 50 years. So the data gappage, or the amount of space between surveys, is massive. But typically when we survey a lake, we spend a fairly intensive amount of time. So typically at least a week. And so we have two different types of surveys that we do. We either do a survey that's called a status and trend survey, which, think of this as a set-wide protocol that's done no matter where you are in the state, using the same methods, the same gear, so the data is really comparable. You can compare it to any other lake that has been sampled with this gear type. So there's that kind of data. And that that data comes from a randomized list that says, this, for example, this year, the lakes on the list are not in Berry County, but the closest one is called Como Lake. It's by Greenville. Lake comes up, we're going to go in and do this protocol. Not because I have a management question, but because it's on this randomized list and we want to get data as it relates. Otherwise, we survey lakes because we have a specific management question, such as, are the fish that we are stocking surviving and contributing to the fishery and producing a fishery? Or questions like, wow, there was a very large fish kill. Is there something going on? Is the health of the system not productive? Does something need to change? So that data often looks like fish numbers, fish catch, age of fish, and sometimes we have information related to the sex of fish if we do surveys when we're able to sex the fish, which is typically at ice out or right now.
So fisheries ecology is really interesting. In my background here is Thornapple Lake, which I understand is like yours, as far as you're the fishery biologist for this lake, and it's a lake that I don't know, I was kind of confused if it is a lake because it's really part of a larger river, but I understand it is a lake, and there's a natural shoreline that we installed there, and I know that you guys stock this lake. So it's just that's really cool. All that stuff. I bet field season is probably your favorite. I know it would be mine. It is mine. I don't get to do that kind of stuff, but I know I got in here, and you probably did too, because we like to be outside. And if we can get paid to do things that are good for the environment and also enjoy our time, that's definitely worthwhile. So as far as the fisheries, in layman's term, can you explain why it's important, and like what are some of the key factors that contribute to a healthy aquatic environment? So that you talked a little bit about the temperature, but what is it that's making that change, or what leads to the differences, I guess, in healthy versus unhealthy aquatic environments?
Yeah, so I think this question is loaded because there's a lot of, I'm not going to even say right answers, but there's a lot of factors that play into fisheries ecology and larger aquatic ecology and aquatic ecosystem health. But if we use Thornapple Lake, for example, which is a approximately 400-acre lake, within the Thornapple River, it's a natural lake that basically occurs within the river, really unique system, has, some issues associated with it. And when you think about it being super heavy, super healthy, like one thing you can first look at is there's development around the lake. It's not necessarily a bad thing. People have properties, they have houses, they have docks, but maybe one thing that could make it healthier is if no one had a mowed and beautiful pristine grass. If it all looked like the picture behind you, Rachel, that would make it healthier, because inadvertently, when you have these kind of pristine looking lawns, you introduce nutrients like nitrogen and phosphorus into the lake ecosystem. And nitrogen and phosphorus then can lead to increases in things like algae, or can lead to more plant growth, which, not that all aquatic plants are bad. So actually, having a good plant diversity is another key thing for a healthy aquatic ecosystem. And as long as they're native, we really are hoping for there to be aquatic plants in the system. Another thing that can influence is, we talked a lot about temperature and dissolved oxygen. When we go and sample a lake, we're interested in seeing how the lake is stratified. So what that means is typically twice a year, most of our lakes stratify. So they have these layers of water. Imagine the top layer, the layer you're swimming in. It typically extends maybe from the surface, maybe 10 or 12 feet down. And it's pretty warm. In the summer, maybe 80 to 75 degrees water temp. And it has a lot of oxygen, normally, more than 8 milligrams per liter, which is quite a bit. Then you reach a very small, thin layer of water that's maybe a foot or two, and it's cooler. Maybe it's about 68 degrees, and the oxygen is plummeting. So now it's only, 3 or 4 degrees, or 3 or 4 milligrams per liter. So it's only at this level is it now slightly suitable for fish to still live there, because most fish need at least 3 milligrams per liter of oxygen to live in. And then after this thin layer of water, from maybe say 17 feet to the bottom, it's hypoxic, meaning there's no oxygen there. And so fish can't live there because there's nothing for them to breathe in. And most aquatic things can't live there. So you have a lake that maybe is 40 feet deep, and you think, wow, look at all that area. But the habitat that fish can live in is actually truncated. And then there might be another truncation because a lot of fish don't want to live in 80 degrees. They want to live more in that 68 degrees. So we think about that in terms of lake stratification and how that relates back to fisheries ecology and how things like nutrient inputs can affect that. It's kind of a long way to not tell you about like the phosphorus cycle, which is terribly boring, but to hopefully show that there is some influence relating back from nutrients into the overall health of the ecosystem. Another thing is aquatic invasive species. So, when you think about maybe you went and took your boat and you went bass fishing on Thornapple Lake, and then you decide, oh, the next day, I'm going to go down to Fine Lake, but you don't wash your boat off and you don't necessarily know what's at Thornapple Lake. And if the same, fish, plant, mussels, you don't know if those are also at Fine Lake. So you might inadvertently be transporting something from one lake to another, and that can negatively impact the ecosystem without even meaning to. And then there's a new, invader or a new species that is going to be really robust and take off because it has more of a new sterile or semi-sterile environment for that species to explode into.
There's a lot there to consider, and I think I've got some follow-up questions to that. But this is Conservation Fridays, and on the other side of this break, we want to ask a couple follow-up questions, and then we're going to get into some more insights about ideal habitats and ecosystems that would support fish populations in our region. But before that, Rachel?
And if you're passionate about protecting the environment and making a positive impact in your community, consider volunteering with your local conservation district. By joining forces with your local conservation professionals, you'll support efforts in natural resource management that safeguards our communities. Whether it's tree wrapping, habitat restoration, water quality monitoring, or educational outreach, there are countless ways to contribute to the preservation of our natural areas. Join our dedicated team of volunteers today and be part of the solution for a greener, healthier future. To volunteer with Berry Conservation District, sign up at berrycd.org/give.
So back to talking about these aquatic ecosystems and fish, Addie. I'm as you're talking and describing these ecosystems and what can happen with them, I'm thinking a lot about the character of water, especially on waterways or rivers, is interesting from the standpoint that, in my experience before I learned everything I know now, and I feel like I observed this in others, and when you read in history, you look at communities that spring up along rivers and they use rivers to move the refuse out. And they don't really think about what's downstream. And we talk about that now when we in Project Wet and other programs like that, when we're educating the public, thinking about what's upstream and what's downstream. And, at some point, everybody or something is downstream of something else. And so what you do has an impact. So I'm thinking about that. And I'm wondering two things. First of all, I wonder if you can share an example of maybe describe a aquatic system that you have experienced that was just really bombed out. Like, what does that look like if somebody was to to walk up on a lake or a river, and the ecosystem there is something that really can't support or thrive. I'm wondering how obvious that is to somebody that doesn't have a background in aquatic ecosystems. What does that look like?
Well, I think that I don't think it would be super apparently obvious unless there was a telltale factor. And I'll give you an example of that first. So something that we deal with often, more often than I would like, is manure spills into waterways. So manure possibly being applied onto a crop field that's directly adjacent to a waterway, and then the manure runs off the field and is into the stream. Well, in this instance, you might notice the manure being present because you could smell it, and you might not necessarily know it's in the stream, but if you were there in the event, very close to when it happened, maybe you would see dead fish and see that as a sign that there's manure in the stream. But if you hadn't seen that, maybe later when you walked through, what you would see is a large amount of algae or brown areas or brown clumping on rocks. And you might think, man, seems kind of strange. Or you would walk by and you wouldn't see any fish kind of darting around when your shadow came across the water. So an instance like that, I think someone might recognize it. A opposite to that, when someone might not understand, like, man, this waterway doesn't seem to be functioning like it should, but you would know it has some issues, is think about walking along a stream that's very straight. Doesn't have any curves. It doesn't look like a bunch of S's going back. You look down it and you can see for, hundreds of yards, if not farther, and it's straight. It has basically just grass banks and no character. It's just kind of like, it's kind of plain. There's not any wood along the, the tops. There's no trees. There's no wood in it. Often streams like that have been designated as maybe drains, or they've been dredged. And so a lot of their ecosystem functioning processes are no longer available to them because they've been manipulated to a point that they can't function properly anymore. They're not reaching the floodplain, meaning that the water is not rising when we get, either thawing or a large amount of precipitation and spilling over into the riparian or the areas next to the stream. That's not occurring because the channel is so entrenched. The sides of the stream are so steep that the water can never reach the top and spill over. It's more like a chute. Mm-hmm. So that would be pretty apparent, I think, for someone, but maybe would be the thought process would not connect fully to say, I hadn't thought, man, this stream's straight, doesn't look like it's got a bunch of S's and doesn't have the ability to come out and reach the riparian area. I think those would probably be the best examples I can think of, at least off the top of my head.
So it's not always immediately obvious what the health of that waterway is necessarily.
No, at least I don't think so. Sometimes I'm even surprised. 2 years ago, we sampled a trout stream, a stream that we had been stocking with brown trout since sometime in the early 2000s. And we got to the stream. I told you earlier, I love to trout fish, love to. We pull up to the stream to sample it, and I'm like, this is not a trout stream. Why are we stocking brown trout here? Like this is terrible. Like instantly I'm thinking like we are just wasting these brown trout. I can't believe we're stocking them here. But I'm like, all right, we got to survey this. It was for a dam removal project, and we were going to do the pre-work to understand what the fish community was like. We strap our backpack electrofishing units on that basically look like you're from Ghostbusters. We hop out there, and now wouldn't I be wrong? We had brown trout up to 18 inches. And I was just,
Oh, wow.
my mind was just blown. I was like, this is crazy. I would have laid money on, if I was a betting person, I would have put money down that there was going to be 0 brown trout, or if there were any brown trout, they were going to be from when we had just stocked them like a few months previous. And I was completely wrong.
That's really cool. I know I have a shoreline certification, so shoreline is something I'm passionate about, and I got to actually go electrofishing once in Indian Mill Creek, which is in Grand Rapids, and I was really surprised to find there were brown trout. Mostly it was white suckers, but I learned a lot about fish that day. And also that frogs cannot withstand the electroshock, which is a bummer, but we only lost one, so not the end of the world. But so when it comes to fish conservation in Southwest Michigan, do you have any insights about the ideal habitat? And you spoke a little bit about plant variety, temperatures, stratification, things like that. But what would your ideal, let's go with streams, because that's where the trout are, right? They're not in lakes.
Oh, they can be in lakes, but
Okay, like I have no idea. So what what does that look like? And then also, what are the biggest challenges or threats that you and the other people who do fishery science work to address?
So I'd say like an ideal trout stream for me would be in an area that has a lot of land protection. So, it doesn't have a lot of development. It's pretty natural, and it winds through areas that, are either mixed habitat or potentially have some variability associated with them. Places that have canopy cover, typically trout streams have canopy cover that are either dominated by, cedar species, or at times can be dominated by deciduous, so, oaks or maples. It kind of depends where you are, but, having some amount of shade is often important for cold water streams. Having really good, excellent groundwater, which in Michigan is more about how you are related back to the glaciers than really anything else, but also can be related to how that groundwater is being utilized. So is it being pulled out of the aquifer for other purposes, or is it predominantly still, within to have good groundwater inputs to keep the stream nice and cold? That's hugely important. The stream would have variability in terms of the bottom substrate. So we would want to make sure there was good, clean gravel for spawning, but we would want to also have areas with sand or maybe large cobble. And we'd want to have habitat diversity. So riffles, which are, fast flowing, typically shallow water, and typically gravel or small cobble. So that's where spawning would occur, but would also be a good place for smaller fish to eat macroinvertebrates coming off of the rocks. You'd have run habitat. So that's habitat that's not super deep, but not super fast. Typically often in the straighter areas or on the inside corners of a stream. And you want to have pool habitat. So areas that larger fish can inhabit throughout the year and also can potentially capture other fish once they become piscivorous or fish eating. And I think you'd want to have, I talked about the shade, but having good riparian diversity and not a ton of erosion. So you don't want a bunch of sediment coming in, or nutrients or pollutants or whatever could be coming in. Having a good riparian buffer to help keep that out of the trout stream. So I'd say that's probably my general good habitat, but it could be altered.
How does that, and you said there could be trout in still water or lakes. Like, what does a good habitat look like in that environment?
Specifically,
How would it differ from the moving water?
Ooh, yeah. So trout lakes are few and far between that we are actively losing them in the southern part of Michigan. And we're actively losing them for a variety of reasons. Species introductions. So places that typically are trout lakes do not equal walleye and northern pike. You know, those predatory species are normally really good at eating hatchery rainbow trout or brown trout, and they get really big really quickly because they are smart and they like to chase down hatchery fish. So that's a major thing that I would want to avoid and have in my trout lake is a really simple fish community, similar to a trout stream, but you'd probably have maybe slightly different species. A lot of our trout lakes also have yellow perch or bluegills, but they typically don't have predator fish species with them. They have typically are deep, really clean, really clear, and they're very low in nutrients, meaning that they're oligotrophic. So that's a type of lake that we describe that's, you know, you think about lakes that you can see 15 or 20 feet down, and they maybe have a little bit of a blue hinge or, you know, tinge to them, basically. And they're normally, this is not always, but they're normally smaller. They're not huge. So I would say those are some of the bigger things. We would also, you know, hope that there weren't any aquatic plant treatments because the lakes typically don't have a lot of aquatic plants because they are oligotrophic, meaning they don't have a ton of nutrients. So what plants they have that are native, we would like them to stay. And similar, like the riparian zones, just like on streams, on lakes, you would want them to be intact as well.
Hmm. So aquatic species invasive species have come up here a few times. Would you consider that to be one of the biggest threats that we face in regard to aquatic organisms and fish in southern Michigan?
I definitely just like blanked on answering that the first time when Rachel asked me. It was just like, boop, she didn't ask me that half of the question. It was gone. Yeah, I would say yes, aquatic invasive species, and in some cases, terrestrial invasive species that affect aquatic species. I think those are big challenges. I don't do a lot of aquatic or terrestrial invasive work hardly at all in my job, but a big thing that we're grappling with at the state level that can't really give you great specifics because I don't work with it a lot, but is Didymo. Trying to understand the impacts of Didymo. And there is some conversation that it actually might be native and we just didn't know that. So that's one. New Zealand mud snail.
I'm sorry. Can you tell me more? I'm being completely novice to this. What's Didymo?
Sure. Didymo is the classic name that you maybe know it by is rock snot. So for anyone who's totally curious, just Google rock snot, and I know it sounds terrible, but it'll
That's why you
come up.
said Didymo.
Um, it's basically this algae that there's very little known about it across the world. The best probably case studies are from New Zealand. It inhabits typically, this is very broad, typically trout streams because, you know, think cold, clear water that's low in nutrients. And unlike like everything you might know about algae, like typically you hear algae and you think, man, there's a lot of nutrients, there's an excessive amount, and it causes a bloom, like boom. And then you have this kind of greenish, maybe slightly blue colored algae that's present. Nope. Didymo likes very low levels of nutrients, and that's when it typically blooms. So it's very irregular, but it can literally create mats of brown looking crap, aka rock snot, on rocky areas. And there's no pattern. Like it might just bloom tomorrow and then it won't bloom for 2.5 years and you won't know why, or we don't currently know why.
Wow.
So.
And that's really interesting. And does it smother out the local species, or what does it do?
Great question. My answer is we don't know fully.
Okay.
There's some theories. There's some theories associated with it could affect natural reproduction of species that use clean gravel, because obviously if you have this kind of brown matting, it's not clean anymore. And so it could affect egg deposition and or egg survival. It also could affect macroinvertebrates, which then are often the base of the food web because it's covering rocks that are home to a lot of key macroinvertebrate species. But the science is really not caught up yet to this species to understand what's going on.
Okay, sorry, I got really interested in rock snot crap, so I'll let you get back. You were listing out the challenges.
Okay, so aquatic invasive species, climate change. We're not doing a lot of actual on the ground proactive understanding of climate change, but we are, we have long-term data sets. So as part of that status and trends program I talked about slightly earlier, we have a streams component where we have these things called fixed sites. So that means we sample a smallmouth bass or a trout stream every year for 3 years in a row. And then we take 3 years off. Then we come back and do every year for 3 years. We have these across the state to try to understand long-term trends. And in part of those long-term trends, climate change. So that's another challenge. Probably the biggest challenge that we have right now is the lack of funding. So there are 14 management biologists, so 14 of me for the entire state. And we manage, I think the number is approximately 1.5 million acres of freshwater per biologist. And so the lack of funding doesn't allow us to really have a good understanding of what's going on these systems because we're there so infrequently. And we just don't have the resources to survey places more frequently or to understand trends at locations other than these few fixed sites that I talked about.
That's unfortunate. I think you talked about a lot of things, and I didn't hear you mention it all, stormwater systems and the load. That's kind of my previous background, so that's always the first on my mind is storm drain, basically non-point source pollution. Can you talk? Well, originally I really wanted to ask about the role of plants and woody debris for fish because I know it's important, but I think I care a little bit more about the stormwater aspect, but whichever one you think is more important because we are running out of time, so sorry.
They're both important. I'll keep it short and saying that, but I will say that stormwater in developed areas is really critical. And the more that Southwest Michigan develops, the more I think that stormwater will become a larger role. Because if we don't have the systems in place to properly filter the stormwater, and if we keep losing our wetland habitat that are our natural filters, then I think we're going to continue to have stormwater issues.
Yeah. Okay, so like Rachel said, we're in the last minutes, but we don't want to get away from here without, learning. We don't want to learn something without putting a handle on it, and figuring out how we can leverage that. So, what for our listeners who, want to support fish and aquatic ecosystems that support healthy fish, and responsible stewardship of our waterways, what are some simple actions that someone can take in their everyday lives?
I'd say the simplest thing if you want to support fisheries is to buy a fishing license. So that's what funds just about all of the work. It's $26 a year. Purchase one, even if you're not going to fish. Second, if you have any amount of outside time and you can pick up trash, or if you have a pet and you can pick up your dog's waste, that's awesome. If you are lucky enough to have property that has any amount of water or wetland or any kind of water feature, conserve, protect, and rehabilitate that at all abilities possible because it matters. Even if it's something tiny that gets water 3 times a year going through it, it matters. So I'd say those are probably the biggest things. And I would say the other thing that you can do is take a kid fishing because there isn't going to be an interest in the future if you don't take, a kid or someone who's never fished and doesn't have any kind of connection to water. Because if they don't have a connection, then they're not going to want to be supportive of that because there's no personal connection to it.
Yeah, I love that. That's perfect. My family's getting ready to go on a backpacking slash a streamside fishing trip here in a couple of weeks. And I'm going to play this for my 16-year-old son, who was like, do we really have to buy a fishing license? And I said, yes, we do. And I think at 16, he'll be 17 and actually before we go on that trip. So he at 17 does need to get a fishing license, correct?
Yeah, and quick hitter on that. If you have a kid and you buy the $2 voluntary fishing license, we get to count your child as a licensed angler. And so the tax on fishing gear, then they get to be counted as an angler. And so it produces a bunch of money coming back to the state for your
Oh, that's
$2
terrific.
contribution.
Good. I'm glad to know that. Excellent. Well, as we wrap up here, are there any upcoming events or projects that you'd like our listeners to know about?
The only cool thing we have coming up in Berry County is we're going to be surveying Glass Creek this year. So first time in 20 plus years. And so that'll be really fun and I'll be happy to report back on that.
Very good. We'll have to invite you back on the show to share what you find out there. Well, next time we convene Conservation Fridays, we will be talking with Dan Zay from Natural Resources Conservation Service about wildflowers and wildfires. That's on Friday, April 5th. And as always, we live stream right here on Facebook and then upload everything to our podcast, which you can find wherever you listen to podcasts. Addie, really appreciate you joining us today. I learned a lot myself. I think our listeners did too.
Thanks for having me. It was a blast.
Rachel?
Yeah, thanks. And I'm really hoping that we can end up working together in the future on Thornapple Lake and surrounding, and I can learn a little bit more. Thanks.
Join us again. Have a good day.